Started with the name of Allah, who is most merciful and beneficial. My name is Zain Ali and my registration number is 2021 mining 21, and my group member is Daniyal Abbasi, whose registration number is 2021 mining 16. We assigned a complex engineering problem of a ground control engineering subject. We design underground mining in the Saskatoon, Canada, where the task is to design underground mine in north of Saskatoon. According to our case history and geology, our ore deposit of potash rock salt is located in north of Saskatoon, Canada at the depth of 600 to 800 meter below. And our country rock contains limestone, sandstone, clay, and some other formations. There are two methods for the injection or excavation of our rock salt deposit. First one is the room and pillar method, and the generally used method in the Canada is the injection method. First, we use our room and pillar mining method for the excavation of potash rock salt. Our pillar width is 25 meter and our pillar length is also 25 meter. And second method is the injection method. In this we can inject the brine into our potash rock salt, and we excavate this potash rock salt with the brine outside from our mining. Second method to excavate our ore deposit is the injection method. In this method, we inject our heated brine into the potash rock salt deposit and we excavate it from the mine. And on the surface, we process this and separate our brine from this deposit, and we get our the deposit of potash rock salt. These deposits of Canada are of very good quality, which are used for the domestic and international level. These deposits are used in animal feeds, foods, fertilizers, batteries, detergents, and soaps. According to our geology, our country rock contains a 60-meter layer of clay, then limestone, then sandstone, and then silt. After this, there are several layers of potash rock salt. According to our geology, 3 layers of potash rock salt are: first one is carbonate rocks. This contains limestone and dolomite. Second layer is of sulfate rock, which contains andirite and gypsum. And third layer contains potash rich rocks, which contains salvite and kernelite. Our deposit type is of tabular shape, which contains the area of 1000 kilometers square, and our potash rock salt deposit is of tabular shape, which contains the area of 1000 kilometers square, and our depth of the rock salt deposit is 5 to 30 degree. There are several rock properties: density, porosity, RQD, Young's modulus, compressibility, and permeability. These rock properties are from the literature review of north of Saskatoon, Canada. There is a sampling plan which includes 3 steps. First one is the site investigation, second one is the sample collection, and third one is the sample preparation. First, there are several methods for the calculation of in situ stress, which are flat jack method, hydraulic fracturing, and overcoring method. We suggest flat jack method for the calculation of in situ stress, and we find the horizontal and vertical stress.
Assalamualaikum, myself Daniyal Solutions. My registration number is 2021 mine 16. I am here to explain about the main content of our complex engineering problem. First is mine design and then rock sport. After knowing the geology of our area, some calculations are done. After doing some calculations, we decided our added opening with a horizontal ellipse to find the horizontal and vertical stresses on our opening. After seeing the depth of deposit, we make a preliminary design in our mind and sketch it. Our deposit is around about 800 meter deep from the surface and separate out 1000 square kilometers. We decided make our added 100 meters below the surface, and then attach shaft with the adit to reach the deposit. Then we find our shaft openings are circular. We find stresses, radial, normal and shear. Radial and shear stresses at the boundary is 0, and tensile stresses will be maximum and the minimum. Then after find the stresses, we can done simulation in phase 2D software, rock science. In phase 2D software, first of all we open the phase 2D software in our computer, then click on boundaries, add external boundaries, make edits, and then make shaft, then apply meshes, displacements, and interpret it. Results will be shown. Then results will be shown. The phase 2D results are showing the first of all horizontal displacements, vertical displacements, maximum shear stresses, and maximum shear strain, differential stresses, volumetric strain. After this, we done some calculations for the room and pillar mining method that are done in the potash salt mining in our design mine. Then after a lot of literature review, we selected the pillar width 25 meters and the pillar height is 6 meters. There are different pillar recovery methods. First is the split and fender method, then second is the pocket and wing method, third is the open end method, and fourth is the open cut method. Then our maximum depth for famous method is split and fender method, then second one is the pocket and finger method. We selected for our mine is pocket and finger method. After making this results can be simulated by using phase 2D software, results will be clear. No need of support. Then after this we will perform this sketch on the AutoCAD and make same design on AutoCAD, and then after this we done infinite element modeling software on by using SolidWorks. Then I see results on SolidWorks, then opening or burst due to high overburden stresses. Then our next part is rock support. First of all, we identify the critical areas of mine that will need support. First, the roof, pillars, wall, interways, haulageways, intersections, and then select a ground plane for potash salt mine. First, the main shaft and head frame, pillars, ventilation system, etc. In potash salt mining, after a literature review, we can find RMR. It's RMR in the range between 87 and 89. So it is the excellent rock. So no need of support. Just in this method, supports are pillars, and we need support on the limestone. Then our edit is in the limestone. We find the RQD of limestone and then find the RMR. Then RMR comes 60. Then see the RMR table. Then RMR table shows it is a pure rock. So need a support. Then 4 meter length bolt and 2 meter spacing with 1.5 meter shotcrete. These simulations can be done on phase 2D software. Adding rock bolts and factor of safety will be greater than 1. And so after this, we conclude everything we are done in our project. First of all, we design underground mine in north of Saskatoon, Canada. Our deposit is potash salt. That is deep 800 meter from surface. And then we design elliptical openings. Elliptical openings are the horizontal ellipse, and then edit shaft for reaching the deposit. And then we apply the room and pillar mining method in our underground mine designs. And then we use a number of softwares, that is the AutoCAD, Phase 2D, and SolidWorks. These are all things which we are included in our projects. That's it.